Hi students. Today we are going to discuss about the topic structure of power system. First of all, you have to know what is power system. The power system is a network designed to generate, transmit and distribute the electricity to the end user. That means from the generation, we are generating the electricity and then we are transmitting that electricity through the transmission line and distribute it to the end users. And then it ensures that electrical energy is delivered from generating station to end users with reliability, efficiency, and safety. So it has some importance to deliver the power to the consumers. Where we're considering the loads such as industrial loads, commercial loads, agricultural loads, and residential loads. So it has the important supports to the industries, hospitals, transports, agriculture, home, etc. And then the end user is receiving the electricity with the stability, economical, and then environmentally it should be sustainable. So in our next slide, we are going to see about the generation. Starting from the generation, it is the first stage in a power system. It has a uh, up to 11 kV we are generating. That is the range from 11 kV to 25 kV. It has the types of power plants such as thermal power plant, hydro power plant, nuclear, renewable, tidal, geothermal. Like that, you can list it out. And then in that thermal power plant, which is considering the sources of coal and gas. For example, we quoted here Neyveli power plants and NTPC plants. Then next one is hydro power plant, which taken the source of water. I will consider the example as Bakrananga Dam and Metu Dam. Next one, third one is nuclear power plant, which has the source of uranium. We can take this example, Kalpakam Nuclear Power Station. And final one is renewable energy power plants. That is, it consider the sources as wind and solar. For wind, it is near in Tamil Nadu. You can consider that is the part of Kanyakumari and then Tarapuram. And then for solar, so many solar parks are there. Here we quoted Kamudi Solar Park. It is near to the Tamil Nadu, Madurai. While these are the types of power plants, we have to know the we are generating the power from this types of power plants. And then it has some base load plants and peak load plants, which can be differ by the operation. The base load plants means it has to operate continuously, like thermal and nuclear. For peak load plants mean during the high demand of electricity, it will operate. For example, gas turbines. And the output voltage of power generation, typically we know that 11 kV. And then the range is 11 kV to 25 kV. It can be stepped up for a transmission up to 765 kV. In future, 1200 kV is under the pipeline. In our next slide, we are going to discuss about the structure of power system. That means after the power has been generated, then we move to the transmission and distribution of electricity. For that, we need that structure, how to transmit and distribute the electric power. This is the diagram, which you can know see that generating station. That is the first thing. We are generating the power uh, up to 11 kilovolt. That is given in the diagram. That 11 kilovolt is stepping up to 132 kilovolt or 220 kilovolt or 400 kilovolt using the step up transformer. Then it is moves to the stepped up voltage 132 kilovolt is transmitted through the transmission line and it reaches the receiving station. This process is called primary transmission, which is having the high voltage. The stepping up and transmitting the high voltage is called primary transmission. Next one is 132 kilovolt, which is received by the receiving station, and then it is stepped down to 33 kilovolt at the receiving station. So this can be stepped down to 33 or 66 kV based on the receiving station. Then this step down voltage is once again stepped down to 11 kilovolt to the substation. This process is called secondary transmission. Next, it reaches the substation with 11 kV voltage. And then this 11 kV voltage is directly given to the industrial consumers from the substation. And then once again, it is stepped down to 415 volt. Then it is distributed to the consumers, that is a single phase and a three-phase loads based on the residential load or commercial load. This process is called secondary distribution. Here in this structure, we are stepping up the voltage at the one time. That is in primary transmission part. That is the 11 kilovolt to 132 kilovolt. We are transmitting that very high voltage in the primary transmission. Then it reaches the at last end user as a single phase or three-phase supply to the residential load. So this is the thing about the structure of power system, how we generated the generated power is reaching the consumer. The next one is power transmission. We discussed in the structure in the previous slide. That is, electricity is transmitted over long distance using a high voltage by stepping up the voltage from 11 kV to 132 kilovolt. The purpose of this transmission, it can reduce the I square R loss, and then it improves the efficiency. Here we are using the key components such as transmission lines, step-up transformers, and then substation. Here the transmission line, which carries high AC voltage, that is up to 765 kilovolt. Then step-up transformer, it increases the voltage for transmission, that is called step-up transformer. Substation, it is receiving that high voltage and it controlling that voltage levels. Then type of transmission, we know that HVAC and HVDC. HVAC is we are using worldwide. The typical voltages, for this power transmission, which is discussed in the structure of power system, that is 132 kilovolt, 220 kilovolts, 400 kilovolt. Next is in this slide, we are going to discuss the power distribution. How we are distributing the electricity from the substation to the consumers. The processes, we know that we discussed in the structure of power system slide. We have the step down substation. There we are reducing that 132 kilovolt to 33 kilovolt. That is, then it is once again stepped down to 11 kilovolt. That is called primary distribution lines. In that secondary distribution, we are converting the 11 kilovolt to 14 volt for three-phase users and 230 volt for single-phase users. So here we are having the service connections such as residential and then commercial loads. And then how we are distributing this power in urban and rural areas. In urban areas, we are using the underground cables due to the dense network. In rural areas, we are using the overhead lines and sparse network. Next, in this slide, we are going to see the key components of power system. First one is key component is generator. It is in the generating station. We are using that. It converts mechanical energy to electrical energy. The generator is a machine which converts mechanical energy to electrical energy. And then next one is transformer. We know that what is transformer? Transformer is a static electrical device which is converting the voltage, which is transferring the voltage from one level to another level without changing the frequency. Whatever we are giving the frequency range, that should be maintained at last level. Then circuit breaker, it gives the protection from the faults, and then isolator, you know that it is disconnecting the section for maintenance. And then bus bar means we know that common connecting point for all the lines. You consider in your classrooms having the wings. In that wing, all the classrooms are connected. Classroom boards are connected in the one point, that is called bus bar. Relays, it detects the faults and triggers protection to the power system. Loads. Finally, we know that final consumption of this electricity is loads, that is residential load, commercial load, and industrial load, and agricultural loads we discussed in the previous slides. These are the key components of power system which is used in the transmission and distribution. Thank you all.